Hello, my name is Terry Falcamata. In this video I will discuss visual analysis of single subject experimental design. Visual analysis of data displayed on graphs is the primary method for evaluating single subject design studies. We use visual analysis while we conduct our single subject design studies on an ongoing basis as the data come in to evaluate whether an independent variable is having an effect on a dependent variable. This is how we determine whether we should do things such as change phases from baseline to intervention, reverse back to baseline, introduce treatment with a subsequent participant within a multiple baseline design, and other actions as we are executing our study. We also use visual analysis as a post hoc method for evaluating the effects of an independent variable on a dependent variable after a study is complete. And we do this with our own studies or evaluations. And we do this when reviewing the work of other researchers during the peer review process or when evaluating the results of published works. For the remainder of this video, I'm going to briefly describe the basic principles of visual analysis of single subject experimental design. When we conduct visual analysis, there are several dimensions that we look at as we evaluate the data as they come in either while we execute the study or post hoc after the study is complete. And these dimensions fall within phase and between phase. When we're looking within phase, the first thing that we look at, or the first dimension, is the level of the data, or the level of the data path. And this refers to the average of the data within a condition. So for example, just to show some hypothetical data here to illustrate this, we see a relatively low level of data. This group of data, they fall between 2 and 6. Again, relatively low in terms of the scale of this particular graph. And to show a second example, we see a relatively high level of data in terms of this data path, where the data fall, this group of data falls between 14 and 20. So you can see here the difference in level of the data within phase. A second dimension that we look at as we are evaluating data within phase is the trend in the data. And the trend is the overall direction taken by a data path. So the slope refers to an upward or downward slant of the data, and it can be a positive slope, it can be flat, or it can have a negative slope. And then the second dimension that we look at in terms of trend is the magnitude. And the magnitude is the size or the extent of the slope. So we can have a high magnitude, we can have a medium magnitude, or a low magnitude in terms of the trend. So just for example here, some hypothetical data, we see an upward trend, and this is a moderately increasing upward trend. So the magnitude of the change is a medium, I would call a medium magnitude. Here we see a second example of a data set within phase where we see an upward trend and we see high magnitude here in the slope. So we have a much more severe upward trend in the data within phase. Again, some hypothetical data. We see here a downward trend in the slope. This is a medium or moderate change in magnitude here in terms of the trend. And here's a second example of a downward trend, negative trend in the data within phase. And these data represent a much more severe downward trend in magnitude in the slope. When looking within phase, we also evaluate the variability in the data. Again, as the data are coming in as we execute the study or post hoc, we look very carefully at the variability within phase of the data. And the variability is the degree to which individual data points deviate from an overall trend in the data. So here's an example of some hypothetical data. And as you can see here, we see very little variability in the data. All of the data points fall between 7 and 8, so these are highly stable data. Here's a second example, and we see that these data are relatively more unstable than this example. So we see the change here in level from data point to data point, suggesting relatively less stable data. Just another example, we see an upward trend here within phase of some data. These are relatively stable. You can see that the data path is relatively predictable. And then here's a second example showing less stable data relative to our other example, where you see from data point to data point we see less predictability. We do see an upward trend in the data, but the stability within phase from data point to data point is relatively less here than this other example. Here's an example of a downward trend data path, and we see that these data are relatively stable. From data point to data point, we see that the data path is fairly predictable and stable in the downward trend. And then we have a second example of a downward trend in data path within phase, and these data are relatively less stable than this example. We see from data point to data point, the data are less predictable, although we do see a downward trend. These data are less stable and more variable than the other example. So again, when we're looking at the data within phase, we look at level of the data, we look at the trend in the data, whether the data are increasing or decreasing, and then we look at the variability or the stability of the data. So the extent to which the data are falling within a predicted area on the graph. And this is particularly important as the data are coming in and we are making decisions about when it's time to change phases. We will focus very closely on these dimensions in terms of visual analysis within phase. But in addition to within phase, we also look at dimensions related to between phase data. So for example, one of the dimensions we look at as we are analyzing data between phases is the immediacy of an effect. And we can see a rapid change in terms of the effect between phases of an independent variable, or we could see a slow effect. And these hypothetical data represent an immediate effect. You can see here that we have a high and stable level within phase here. And then when we put in our hypothetical intervention or treatment, we see an immediate drop in level. So we see a very quick and immediate drop. These hypothetical data represent a slower effect of an independent variable. So again, you can see we have a high and stable data. We put our intervention in place and we see in fact an increase and then a slow decrease in the data. And depending on what the independent and dependent variables are, this is a pattern that we might expect. Another dimension in terms of between phase data is overlap. And we look for overlap between data paths, between phases. There could be no overlap, there could be partial overlap, or there could be complete overlap. So for example, these hypothetical represent zero overlap in the data. You can see that there's clear differentiation between these two data paths across phases, zero overlap here. Here with these hypothetical data, we see an example of a little bit of overlap, some partial overlap here. As we see with our hypothetical data, we have high and stable data here, and when we implement our intervention, we see several data points here that overlap in terms of the range of these data, and then we see the gradual decrease in the overlap basically ceases here with the third or fourth data point into intervention. And here's a third example to illustrate total overlap. You can see here with our first phase, we have quite a bit of variability. When we put our hypothetical intervention in place, we see that all of these data basically fall within the same range as the data here during the initial phase. So this is what we would call complete overlap in the data. So again, we have several dimensions that we use to analyze data when we are conducting visual analysis. We look within phase as the data are coming in and post hoc. We look at the level, so where the data fall on the graph. We look at the trend, so the direction of the data, either upward or downward. And we look at the variability or stability of the data within phase. And then we also look between phase. And the two things that we really focus on are immediacy of the effect. So how quickly do the data change after the intervention is implemented? And overlap. So what is the extent to which data collected in one phase fall within the range of an initial phase? Okay, let's look at some actual data, and we will look at these data while considering the dimensions that we use when visually analyzing graphs that I just discussed. So on this graph, we're going to be looking at two data paths. One data path, the closed circles, is going to represent elopement or challenging behavior exhibited by the participant in this study. And the open squares is going to represent communication, appropriate communication. And this example is going to use an ABAB design. So if we take a look at our baseline, we see 4 data points. They're all falling around the same level here with one outlier, but the level here is pretty much between 1 and 1.5 responses per minute. We see relative stability, as I said, with one data point. So as these data were coming in, we made the decision to go ahead and change phases based on the level, the stability, and the trend. Now as we look between phases, after we implemented our intervention, in this case functional communication training, we see an immediate drop in challenging behavior. So we see an immediate drop and we see a change in level and we see relative stability here in the data during our intervention. We also add in our adaptive behavior data that we began collecting here, and we see high levels of communication. When we return to baseline and remove the communication, we see an immediate effect and return to baseline levels. In fact, a bit of an increase in the level here relative to the first baseline, but we do see an immediate effect. We see relatively stable data, all falling within the 2 to 2.5 responses per minute range, and we see a good deal of stability here as well. When we reversed back to the treatment, we see an immediate drop in challenging behavior back to the same levels that we observed in the initial intervention, and we see relative stability, we see the immediacy of effect, we see the low level of challenging behavior, and in addition, when we look at the communication, adaptive responding here, adaptive behavior, we see high levels of appropriate communication. So if you look at these data now in terms of post hoc, we see that during initial baseline, we see this level of behavior, this amount of stability, relatively stable. We put treatment in place, we see the immediate co-occurrence of a drop in challenging behavior. We put baseline back into place, we see an increase in challenging behavior back to the levels, in fact, higher than what we saw initially, and then we see the change in level, immediate change in level back when we put the treatment in place, and we see a good deal of stability at the low level. Okay, let's look at one more example of actual data from a study we conducted. On this graph, we will see data that represent percentage correct on quizzes, so academic responding. And we're going to be looking at data within a multiple baseline design. So as you can see here, we first collected baseline data across 3 different participants. If we look at Emmanuel's data, we see a relatively stable decreasing trend in correct academic responding. With Juan, we see relatively stable data that are occurring at a relatively low level. And with Kenny, we also see relatively stable data with one outlier here. All of the data are falling within a relatively consistent range here between 35 and 60%. When we now add in the data from the intervention, we see with Emmanuel an immediate increase in the data, an immediate increase in level. We also see stability within phase here at this level. With Juan, when we look between phases, we see an immediate effect of the intervention as we see an immediate increase in responding, in academic responding, and we see, although we see a bit of a decreasing trend here with these 3 data, when we look at all of these data as a whole, we see relative stability at this level. And we look at Kenny's data, we see an immediate effect of the intervention as the data increase in level up into the 65 to 90% range. We see relative stability within phase, and we see a relatively level slope. So taken together, these data suggest that the independent variable did have a positive impact on the dependent variable across all 3 participants, as we see immediate changes in the positive direction with academic responding across all 3. We see relatively stable data in baseline with all 3 participants, and we see relatively stable data during the intervention with all 3 participants. Well, that's it. I hope you enjoyed my presentation on visual analysis, and happy analyzing.